Hello friends, my name is Mr. Dhawale, Department of Chemistry, RBNB College, Sri Rampur. In today's lecture, we are going to discuss regarding transannular effect, which is already focused in last lecture, but we take one example regarding this. Now we take another example of transannular effect with bicyclic ring system. If we have 10-membered ring system and 11-membered ring system, as we seen earlier, this type of transannular effect and this type of chemical and physical properties which are differ from the other ring size. Okay, so only medium sized rings are shown such a type of different properties, and that property contain transannular effect. And here suppose we have one example. This is one of the 10-membered ring system, and in case of such type of 10-membered ring system, suppose we have double bond at this position, and if that starting material will react with the per acid. When per acid reacts with this type of ring system, which is medium sized, okay, double bond which can be converted in presence of per acid into the epoxide. Okay, so we have corresponding epoxide. So here this is an epoxide. Okay, so this epoxide which contain, now the crucial step which is shown here. Why? Because here suppose we have such a type of oxygen, and here this is your per acid, and the last oxygen atom which encountered by this double bond and which is attacked by this double bond, and this type of attacks are possible. Okay, and here such type of resonance we have shown like this, and here we have this type of acetate ion, and at that time it will attack. In case of normal rings, suppose we take normal ring systems at that time, or epoxides, suppose this is one of the epoxide. At that time, acid or acetate will easily attack on this epoxide, and it is given out, or it gives such type of product we have. Suppose this is one of the hydroxyl, and here we have another hydroxyl group or acetate ion when we react this with acid. But now here such a type of normal product we don't get. Here this acetate ion will attack first on this carbon atom. Why? Because this carbon atom is very close to this one, so that if we attack or if we transfer this proton, okay, suppose we can transfer this proton on this carbon atom, at that time epoxide ring will open from this side, and we get a different product like this. Suppose we have one product which is not desired one. Okay, suppose we have hydroxyl group here, and acetate ion, we write here the transferred or shifted hydrogen, and here this acetate will present. Okay, and after hydrolysis we get product like this. Here we have hydroxyl and here we have hydroxyl group. Okay, so what is the diol positions? 1, 2, 3, 4 and 5. So here 1, 5 diol we get here, but here in this case we get different product. Okay, here we have as a product we get here 1, 6 diol. So how we get this one? Okay, from this the hydride shift is different. If these two ring size are same, at that time we get 1, 5 diol, but here in this case the hydride shift is carried out at the 1, 5 hydride shift is possible, and in this example here 1, 6 hydride shift. Okay, now in such a type of cases the ring size will change, or it will accommodate like this. Two, 3, 4, 5, 6 and 7. Okay, like this. So here the epoxide you see shown here, and here these two protons are present, and now you attack like this. This proton will attack on this carbon atom, which is 1, 5 H shift occur, and now this epoxide ring will open from this side and we get product like this. Okay, here we have 1 hydroxyl group, here your acetate group is here, and like this we get this product. After hydrolysis we get your desired product, which is 1, 6 diol. Okay, so here this is 7-membered ring system and this one is 5-membered ring system, which is not possible in such cases. And if we take the example like this, at that time you have such a type of different ring systems are occur, and if 7 and 5-membered ring differentiation is possible, at that time we get only the 1, 6 diol instead of we get 1, 5 diol. Okay, so you remember this one. Such type of examples are also possible by transannular effect. Why? Because the protons or hydrogens present on this carbon atom are very close to this 6-number carbon atom, and that's why we get here 1, 5 diol. If the 6-membered ring is converted into the 5-membered ring system, at that time we get here different product like this, and we get here diol 1, 6 diol. Okay, but now if we get this type of product, at that time you see here preferentially this type of two protons which are very close to this 6-number carbon atom. But now if the 6-number carbon atom is very close, at that time we get here 1, 5 diol. But if the ring shape is changed, at that time this 5th carbon atom which is very close to this type of protons. Okay, so you see the transfer of this or shift of this proton is possible only towards this 5-number carbon atom, so that we get here 1, 6 diol as a product. Okay, so you remember this type of examples, and also so many examples included in transannular effect. Okay, another one very simple example we have. Suppose here one hydrogen is replaced by the deuterium, at that time we get different product by the shift. Okay, so here we have one methyl group is there, and here one hydroxyl group is present, and here one deuterium, here we have OH. At that time, suppose protonation is carried out, at that time first this hydroxyl group will abstract this proton and will get converted into the water molecule OH2. Okay, and it will leave very easily. Why? Because it carries positive charge, so which is unstable. And now when this OH minus will abstract this proton, at that time it will convert into the carbonyl group, and here deuterium is shift towards this carbon, and this water molecule will lift out. So here we get this another product having deuterium shift is possible, and here oxidation of hydroxyl group into the carbonyl is possible, and such a type of examples are also possible in this case. Why? Because the carbon 1,6 positions are very close to each other. That's why there is possibility to shift deuterium to the 6th carbon atom. Okay. These type of examples are present in transannular effect. We will see on next lecture. Okay, thank you.